Ja, guten Tag, liebe Kolleginnen und Kollegen. A warm welcome from me, Martin Visbeck. Moin, moin, as we say in northern Germany. Although it's snow in Kiel, I heard this morning, but not here in Bonn. It's my great pleasure to take you into a journey into digital twins of the ocean. We heard quite a bit about digital twins in a more generic sense, and we had a great example about the city. So now Dawn and I want to take you into the journey of the ocean. 70% of our planet's surface is covered by the ocean. So you might think, why isn't there already a digital twin of the ocean, given that it is the biggest surface of the ocean? I think Dawn and I will introduce to you what we're already doing in that space and why we think it is very exciting. As we just heard from the digital twins of the city, there is no digital twin of anything without observations. And over the last 2 or 3 decades, the marine scientists have been really in a fantastic situation to be able to look into the ocean and explore the ocean. Well, Dawn has been to the deepest part of the ocean herself. In a submarine, I only go on ships on the surface and have robots in the ocean. But I think together we're collecting more and more data of the ocean from space, from in situ, and that even allows us to even think about generating digital twins of the ocean in this case. Now, the next thing that you need for each digital twin, and more so for the dynamical ones that we just heard about, is a prediction capability, is a simulation capability. And here we have an increasing range of ocean models that can simulate the dynamics of the ocean from the global scale right down to the local scale. So again, that makes it possible to even think about digital twins of the ocean. And the last reason why is it that we're interested in digital twins, and I think it is interesting for a number of reasons. For ocean literacy, to understand what is happening in the ocean. For management of the ocean, just like city planning, we're doing that also in the ocean space. And also for the private sector, governments and alike, to really forward look into the ocean. So that's the idea that motivates us to really plan for the future, which in the opening video was so well articulated. So in that sense, what is a digital twin? I don't have to explain that to this audience, given that we're here discussing the next 2 days digital twins. They're a virtual representation of a real objects. They need data to inform them, and if they're used for management, they can feed back into the system. So same thing is true for the ocean. And what I find critical, digital twins allow you to answer what-if question. Was wäre wenn? And these what-if questions, I think, are the hallmark of digital twin, really future-proofing development. So the first digital twin example I'm going to share with you is one on the planetary scale. And the what-if question is very simple. What would the global planet's temperature look like if we put more CO2 into the atmosphere? And you've seen the results from these digital twins many times. So also in our climate ocean space, digital twins are popular, but we didn't call it like that. But it's a what-if question. What happens? The planet warms, a lot of CO2, and if we mitigate, congratulations to Esri, net zero by 2030. We're going to be on that green trajectory, hopefully, and that means global warming will hopefully stay below 2 degrees. That science is enabled by digital twins, in that sense, an Earth system model. Now let's take it a bit more closer to the ocean space. One of the consequences of CO2 in the atmosphere warming planet is sea level rising. So now the challenge is, and I wonder what it is in Hawaii, but certainly no problem here in Bonn, but in Hamburg it is a problem. And that is, the question is, what is the most cost-effective way to mitigate climate change, or socially acceptable way? And here, the digital twin works like that. You have a global forecast of what sea level rise is going to be, most likely almost 1 meter more than we have today by the end of the century. And then the question is, what does that mean for a city, and what is a defense mechanism? On that slide on the side, you see you can build a dike, but you can also put sandbars out. You can do nature-based solution like coral reefs or mangrove forests, not so much possible in Germany, but also retreat. And out of these 4 or 5 options, the question for each part of the world is, what is my best option? The Netherlands said, no more dikes, sandbars. Germany says dikes, no sandbars. Different conclusion using digital twin type technology, and we want to enable that around the planet. My third example is more in the area of low carbon energy, wind capture systems at sea. And you see here that we can use these wind capture systems to do both. Capture energy, but also bring spaces to life where we can use the spaces in between them. So the question is, how can we best implement these wind capture systems at sea? And the way you do that, you have a digital twin for each of the wind capture system. That's what the things companies, the companies who build the twins have. But they're now asking the question, how do they impact the environment? How close can they put them together? What's the maintenance schedule? And what opportunities do we have in these areas that are now closed off from other uses to do nature-based solutions, mariculture, and the like? So these are great problems that we can use digital twins of the ocean to inform our marine spatial planning, our uses of the ocean, the human interventions. And in digital twinning, you're trying to future-proof human intervention. So these were my examples, and now we're moving to another part of the world. Dawn, over to you.
Vielen Dank. Vielen Dank, Martin. And thank you for accommodating our English. I thought that you would like to hear about the last wild place on the California coast. This is also a laboratory for a digital twin that is currently in progress. And this is the Jack and Laura Dangerman Preserve, which Jack and Laura purchased a few years ago and then turned this property over to the Nature Conservancy to manage, but also to build this very special digital twin. Now, California, where I'm from, where Esri headquarters are, this is also not far from the Jack and Laura Dangerman Preserve. So this is an index map for you to show this portion of the West Coast. And if we zoom in, this is where the preserve is at this elbow or this bend in the California coast. This is a very, very special place. And you can see on the map that the Jack and Laura Dangerman Preserve is a terrestrial area, but it is also right next to a marine protected area. So this is a continuum of protection across both the land and the ocean. And so for the digital twin in progress, this is a beautiful example of a coastal digital twin. This convergence is very, very important. In fact, this is one of the most important ecological connectivity points in the world. There aren't very many places like this where there's a migration of species both on land and in the ocean that is pointed right at the Jack and Laura Dangerman Preserve. This is a biodiversity conservation hotspot. It is a very, very important climate connectivity and conservation connectivity place. So again, a perfect place to experiment with a digital twin. And this is a conceptual diagram of the digital twin as it is currently functioning. This is by my colleague Kelly Easterday of the Nature Conservancy, also working with us at Esri and with many universities on the California coast. And at the bottom of the diagram, this is what is powering this digital twin, a whole series of sensors that are placed throughout the preserve, and there are more sensors that are going to be placed in the ocean, in the offshore portion of the preserve. The middle part of the diagram, you're very familiar with these in terms of the software and hardware architecture. And this digital twin is being run by ArcGIS Online, also ArcGIS Enterprise. And then everything moves up to the top part of the diagram to show you the data distribution portion of this digital twin. This is a map that shows you where the sensors are currently located. These are sensors that are located in artesian wells, on rivers and creeks. There are rain, precipitation sensors all throughout the preserve here. This is basically capturing for us a digital twin of the watershed, the Jack and Laura Dangerman watershed. There are other digital twins that are in progress here, but this is the first one. So we're very excited about this. And in terms of the data, all of these are free, open, accessible data according to the FAIR data principles: findable, accessible, interoperable, reusable. And this is also a data portal with a name that I absolutely adore. It is the Research Repository for Data Discovery, or for us Star Wars fans, the R2-D2 repository. I also wanted to talk a little bit about another digital twin that is in the Caribbean nation of Grenada. And for this, I'm going to play a video that will be narrated by my colleague, Nathan Shepard.
Let's fly into Grenada and interact with both the original sensor data and the derived GIS content that makes up the 3D digital twin of the island. The initial elements are aerial imagery and the elevation surface, plus the dense LiDAR point cloud content being shown on top of it. This data all came from the recently acquired aerial survey for the island, and it serves as a foundation for Grenada's 3D base map. LiDAR points look realistic when showing the captured RGB colors, but they become more powerful when they are classified into the type of objects that they've hit, be that vegetation, building, or power line. With classified LiDAR, GIS features can be extracted from the point cloud. Individual buildings can be identified and assigned an address and an owner, as well as an estimated location and size of trees, and then these can be used to plan for a more resilient future. For example, we can model a 4-meter storm surge and see what it might do to infrastructure. A virtual world can be used to model and analyze real-world problems before they happen. Analysis can be run on the derived elevation surface from the point clouds to detect potential hazards such as landslide areas. As we fly along and see where landslides are more likely to occur, the 3D base map helps us understand the potential risk to people and property. And such analysis can be scaled out for the entirety of the island. The same is true for flooding potential from rivers and waterways. Knowing where they are, how they could spread out in a flooding situation, and what buildings and power lines could be impacted helps with better planning and risk management. Tourism too can be served by highlighting hidden gems like Grand Etang Lake. A digital twin model connected with the expertise of people who understand what potential disasters and planning challenges the island faces allows the nation of Grenada to plan for its future in the best way possible.
So this is another wonderful example. It's right along the lines of what Martin was showing you in terms of the importance of sea level rise modeling and how digital twins can really make the difference in terms of effective decision making. And the decision making that is being done in Grenada, this is a project of the Grenada Central Statistics Agency along with the Ministry of Land and Agriculture and Esri. One final example that I'd like to show is further offshore. We at Esri headquarters, in collaboration with the U.S. Geological Survey and many other organizations that are on the bottom of this slide, have created a 3D digital ocean. And this is based on observations that Martin and many of his colleagues make in the ocean via buoys of temperature, salinity, dissolved oxygen, and the 3 major nutrients of the ocean. And this is a way that we can use this digital twin as a basis for marine spatial planning that Martin has talked about, for marine protected area design and designation and monitoring, and many other uses. And we are connecting this particular digital twin to the coast so that we have a full ocean to coastal watershed digital twin for areas across the entire world. So, Martin, I think it's back to you.
Yeah, just quickly, colleagues. Thank you, Dawn. So I think Dawn and I gave you what it takes to get a digital twin of the ocean system. Ocean observations are critical, and to feed in and fill in that data lake that the digital twins are feeding off, it's very clear that we need a strong engine to process all the data, so it's an HPC requirement that we have, but certainly also model simulation capabilities that need to feed in, and I think when all of this comes together, we can make the wonders of a digital twin a reality. So I think the ocean is a great space to apply digital twin technology. We have international programs, ditto, and we'll both be talking more about it this afternoon, right, in the session. Thank you very much.
Thank you. Vielen Dank.
Thank you very much. Your work is so exciting, and of course we're short on time, but allow me one question each, Martin, regarding ditto. What do you consider the biggest challenges? And are you rather more optimistic or pessimistic that we will be able to face them?
I'm always an optimist. As a climate scientist, you have to be. But I think for digital twinning, I think the biggest challenge and opportunity is to work on data interoperability, standard setting, interoperability between twins, between data sets, ontologies, that space that you know, guys know very well, and girls, that needs to be advanced more to make digital twin of the ocean a success.
Thank you. And Don, I'm curious about the Jack and Laura Endangerment Preserve, which is like really a fascinating project. But when you read like the marketing text on the internet, it says the goal is to leave it untouched. That's not exactly what you're doing, right?
That's a very good point. What we are trying to do actually is to restore the preserve to the state that it was when it was relatively untouched by the indigenous people who lived in that part of California. So we're doing a lot of restoration. The Endangerment Preserve used to be a ranch, a cattle ranch, and there were many other uses of that land over the years, but we're right now removing a lot of the invasive ice plant, bringing back all of the other natural vegetation, monitoring the wildlife movements there. It's a wonderful natural laboratory.
And I'm really looking forward to hearing more about all your projects in the future. For now, I would like to say thank you from the bottom of my heart. Thank you from the bottom of our oceans to both of you.
Thank you.
And we're very happy to see you later on a different stage and hear more about it. Thank you very much. Martin Visbeck on Wright. Thank you.
Thank you.
Go that way.
This way.